Hello students, I'm Chanchal Das, Assistant Professor, Civil Engineering Department, Dr. B.C. Roy Engineering College, Durgapur. Our today's lecture will be principal planes and stresses. What is principal plane? Actually, if a body is in a strained condition, that means it has been applied some forces on that body, then each and every planes on that body will be having some forces, basically normal force and shear force, the tangential forces on that plane. So there exists some plane where the shear force value is 0. That means there will be no shear forces, only the normal forces. That type of plane on that body will be called principal plane, and the stresses acting on that plane will be called the principal stresses. Now, to find out the principal planes and stresses, we can apply two type of method. One is analytical method, and second one is graphical method. We will be discussing the analytical method first. So finding out the principal planes and stresses by analytical method, we need to first of all understand how to calculate the stresses, normal and shear stresses on a particular plane, which is suppose oblique section. Suppose in this body, in this particular body, we're having one force, that is P, tensile force, and we're taking an oblique section, that is FG, which is having a theta angle with EF, the vertical cross section. Then what will be the stresses? The normal and shear stresses P, this is the forces P and PN and PT. Then what will be the forces in this plane, on this plane? Then we can find out the other things. So to find out the normal and shear stresses on that particular plane, we can take this triangle EFG. Now when we are applying the force P, the stress, the normal stress according this cross section will be equals to P divided by EF. That means the force divided by area. If we are taking the thickness unit 1, then stress will be equals to P divided by the breadth, that is EF. Now if we take this triangle EFG, then the force P will be acting like this, and this P will be having two component on that plane, one normal to the plane and one will be tangential to the plane. Then what will be the value of Pn and Pt? The value of Pn, the value of Pn will be equals to P cos theta. Why so? As because if this angle is theta, this angle will be theta. So if this is P force, this component will be P cos theta, and Pt value will be equals to P sin theta, right? Okay. Now what will be the stresses? What will be the stresses, the normal and shear stress on that particular plane? The normal stress, if we denote this with sigma n, this will be equals to P cos theta divided by Fg, right? and the tangential stress, that is shear stress, will be equals to, if we denote this with tau, this will be equals to p sine theta by fg. Now, what is the value of fg with respect to ef? In this particular triangle, we can get a relation between ef and fg, that is fg will be equals to ef divided by cos theta, right? What we are getting the value of sigma n and tau with respect to this ef. We're getting sigma n is equals to p cos theta. If we put the value of fg over there, so we will be getting ef divided by cos theta, that is p by ef cos square theta, right? Now, what is p by ef? P by ef, already we know that is, this is the sigma value, that is the, if we cut the cross section, then at the cross section the direct stress will be sigma, so we can put the value of sigma over there and we can get sigma cos square theta. So the relation between sigma and sigma n is this: if the plane is having theta angle with the cross section, right? What will be the value of tau? The value of tau will be equals to p sine theta divided by, if we put the value of fg over there with respect to ef, so this will be ef divided by cos theta. So this will be p divided by ef sine theta cos theta, right? Now, what is this value again? This value is sigma, so we can get sigma sine theta cos theta. Now, if we again derive this, this will become sigma sine 2 theta. Now, this is the value of tau. If we know the value of sigma and the angle of that particular plane, we can find out the value of tau. So this is the formula by which we can find out the normal and shear stresses of a particular plane, oblique plane, right? Now, from these equations we can see that the value of sigma n will be maximum when this value will be 1, cos square theta will be 1, so sigma n will be maximum if cos square theta will be equals to 1, that is cos theta will be equals to 1, that is theta will be equals to 0. That means if this angle will be 0, that is the vertical plane, at that vertical plane we are getting the maximum value of sigma n, and the value of tau will be maximum where if this value sine 2 theta is equals to 1, right? Where that means if the value of 2 theta is 90 degree or 270 degree, it's because at 270 degree this sine 230 is also 1 minus 1, but 1, okay, the maximum value will be there. That means if the value of theta is 45 degree or 135 degree, then we are getting the maximum value of tau, right? So this is how we can find out the value of normal and shear stresses of a particular oblique plane if a body is subjected to one tensile or compressive force in one plane. Now what will happen if that body is having two forces or two stresses in two directions? Suppose at x direction the stress is sigma x, and at y direction this is sigma y. Then what will be the value of a particular what will be the value of forces of a particular plane? Suppose the plane, again we are taking a plane which is fg, and we are taking another plane that is a vertical plane from which this fg is having theta angle. This is ef, right? Now again, if we consider the triangle EFG, this will be equals to theta, and two forces are acting over there, that is one in this direction. Suppose this is px, the force, these are the forces, right? And py. Now what will be the value of px and py? Px will be equals to sigma x into ef, as because this sigma is acting in this section, so obviously this will be equals to stress multiplied by the area if we take the thickness unit. So sigma x into f, and py will be equals to sigma y into eg, right? So those will be the value of px and py, right? Now what will be the value of Pn, the force acting normal to this plane Fg, and what will be the value of Pt, that is the force acting tangential to the plane Fg? What will be those values? The value of Pn will be equals to, obviously this Px will be two component, one will be in this direction, one will be in this direction, and py will be having two component, one will be acting in this direction and another will be acting in this direction, right? So if we consider px, the component, this, if this angle is theta, this angle will be theta, right? So we will be having px cos theta, and due to py, if two component we can set for py, one will be acting in this direction, another will be acting in this direction. So if this angle is theta, this angle will be theta, right? So for py we will be having py sin theta, right? Now if we put the values of px and py over there with respect to sigma x and sigma y, we will be getting sigma x ef cos theta plus sigma y eg sin theta, right? And if we find out the value of pt, the tangential force, this will be equals to px sine theta, as because this is theta, so this will be px sine theta plus okay, let us take as plus, then see what is happening. That py will be having two components, one will be acting in this direction, another will be acting in this direction, not in this direction. So this direction is different, so we will have to take negative sign for this component, and this component will be equals to, as because this is theta, this will be equals to py cos theta, right? So basically px sin theta minus py cos theta. And if we put the value of px and py again with respect to sigma x and sigma y, we will be getting sigma x ef sin theta minus sigma y eg cos theta, right? Okay, now those are the forces, right? Those are the forces. Now what will be the stresses? That is the normal stress and the shear stress on that plane. Those will be equals to, if we take sigma n, the normal stress, as sigma n, this is the normal stress, on the plane FG, then sigma n will be equals to Pn divided by the plane, that is FG, right? And what is the value of Pn? We have already find out. This value is basically sigma x ef cos theta, right, plus, okay, let us take this sigma y sin theta divided by fg. Right, now if we split these two things, we can get sigma x ef cos theta divided by fg, and plus sigma y, this will be sigma y eg, so we have missed the term eg over there, so this is sigma y eg sin theta, right, divided by fg. Now what is this ef by fg and what is this eg by fg? ef by fg for this particular triangle, if this angle is theta and this is 90 degree, so ef by fg is nothing but cos theta, and eg by fg is equals to sin theta. So if we put this as cos theta and if we put this as sin theta, what we are getting? We are getting sigma x cos square theta plus sigma y sin square theta, right? Right. So again, if we convert these two values, we will be getting sigma x 1 plus cos 2 theta divided by 2, and sigma y 1 minus cos 2 theta divided by 2, right? Now what we are getting, basically, if we simplify this, this will be sigma x by 2 plus sigma y by 2 plus sigma x by 2 cos 2 theta minus sigma y by 2 cos 2 theta, right? Now if we again simplify this, we will be getting sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. What is this value? This value is sigma n, right? This value is sigma n. And what will be the value of tau then? The value of tau, similarly, this will be equals to pt by the plane area, that is fg, right? And we have already done this value of pt over there. This value has come sigma x ef sin theta minus sigma y eg cos theta, and if we divide this with fg, we will be getting this, right? Again we are getting two terms, that is eg by fg and ef by fg and eg by fg. Ef by fg, we have already seen those two values. This is cos theta, this is sin theta. So we will be having sigma x sin theta cos theta minus sigma y sin theta cos theta, right? So if we take common this will be sigma x minus sigma y sin theta cos theta, right? Now multiplying 2 and dividing with 2, multiplying and dividing with 2. Then what we are getting? We are getting sigma x by sigma y by 2. We are dividing 2 over there and we are multiplying 2 in this, so 2 into sin theta cos theta. So what we are getting? We are getting sigma x minus sigma y by 2, and for this term we are getting sin 2 theta. What is this value? This value is nothing but tau. So we are getting the value of sigma n and tau for this particular plane fg, oblique plane, which is having theta angle with the cross section, vertical cross section, right? And the body was applied with two forces in two directions, right? Now what will be the value of maximum value of tau? The maximum value of tau will be if, again, if this value is 1, that means sin 2 theta is equals to 1. That means if the value of 2 theta is 90 degree or 270 degree similarly, so this value will be equals to 45 degree or 135 degree. So this value will be maximum at an angle 45 degree and at an angle 35 degree if the value of theta is those two values, right? So these are the condition if a body is applied with the direct stresses in one or two directions. So, till now we have discussed about those two cases where a body is subjected to direct stress, that is in one direction or two direction. But what will happen if the body is experiencing some sort of shear force? Suppose only shear force. Suppose one body is there, A, B, C, D, and this body is experiencing some shear force. Suppose tau xy, tau xy. We all know what is shear force. So tau xy is acting on plane ED and BC. Now this the shear force will be accompanied by one balancing shear force that will act in this direction and in this direction, tau xy, right? Now what will happen, or what will be the forces for a particular plane? This, suppose this is E, then what will be the forces on plane EC? To find out this one, we can again extract the triangle. In this case, the triangle will be ECB. Now in this triangle, two forces will be there. Due to the shear forces, two forces will be there. One will be acting in this direction due to this tau xy. This will be suppose Q1, and due to this tau xy there will be another force, that is Q2, right? Now what will be the values of Q1 and Q2? The Q1 will be equals to the force multiplied by area, in this case tau xy, multiplied by the area, that is BC, multiplied by the thickness, which is one we are considering, and Q2 will be equals to tau xy multiplied by the area for this particular triangle, that is EB, right? So those two are the forces acting, right? Then what will be the value of normal force Pn and tangential force Pt on that particular plane EC? So to do so, again there will be two components for this force, Q1 and Q2, right? Value of Pn, if we consider, then for Q1 there will be two components acting in this direction and in this direction, that is perpendicular to the plane and parallel to the plane, right? So the component, if this angle is suppose theta, so this is theta, so if this is theta, this value will be Q1 sin theta, right? Okay. Then due to this Q2 there will be again two components, one will be acting perpendicular and parallel to this plane. This value, perpendicular force, will be equals to Q2 cos theta, as because if this is theta, this angle will be equals to theta, right? So this value will be this. Now putting the value of Q1 and Q2, we can find out the values are tau xy multiplied by BC sin theta plus tau xy EB cos theta, right? Again PT, the value of PT, the tangential force we are considering in this direction, PT, so this value will be equals to this force of Q1 and minus this force of the component Q2, as because this is in different direction. So basically this value will be equals to Q1 cos theta as because this is theta minus q2 sine theta as because in this case this is theta, right? So this will be the value. Putting the value of q1 and q2 over there again, we can get tau xy into bc cos theta minus tau xy into eb sin theta, right? Now what will be the value of sigma n? What is sigma n? Sigma n is the normal stress on the plane EC. Sigma n value will be equals to the force divided by area EC, right? So this value will be similarly like the last method, last example. We can say this will be tau xy bc sin theta divided by EC plus tau xy eb cos theta by EC. Now again we are getting BC by EC and EB by BC. Basically BC by EC for this particular triangle, if this is theta, this is what? This is basically cos theta, right? If this is theta, then BC by EC will be equals to cos theta and EB by EC will be equals to sin theta. So basically we are getting sigma tau xy sin theta cos theta plus tau xy sin theta cos theta, right? So basically 2 tau xy sin theta cos theta. Now if you consider 2 sin theta cos theta, we will be getting this value as tau xy sin 2 theta, is because 2 sin theta cos theta, we are getting sin 2 theta. So this value sigma n will be equals to this, right? Now what will be the value of tau? The value of tau will be similarly Pt divided by the area EC. This is equals to tau xy bc cos theta divided by EC minus tau xy eb sin theta, right, divided by EC. Now again we are getting two terms, that is BC by EC and EB by EC. Already we have discussed that this value is cos theta and this value is sin theta. So we are getting tau xy cos square theta minus tau xy sin square theta. So this will be, if we take the tau xy as common, so this will be cos square theta minus sin square theta, right? So this is nothing but tau xy cos 2 theta, right? So this is the value of tau xy. Now we can find out the maximum and minimum value of tau, right? Where will be the value of where will be the maximum value of tau? If this value is 1, cos 2 theta is 1, right? And cos theta will be 1 at theta equals to 0 degree, right? This is the way. Next case, we are applying direct stresses and shear stresses at the same time. So this is a body A, B, C and D. So these bodies having direct stresses in x direction sigma x and y direction sigma y, right? And shear force which is tau xy and so direct stresses and shear stresses we are applying, right? So what will happen in this case? What will happen to this EC section which is having theta degree angle? So we have taken this triangle over there, and we have to we will try to find out what will be the stresses, direct, normal and shear stresses on this particular plane, right? So this plane is this plane is having this Pn in normal direction and Pt in tangential direction, and we have to find out the values of Pn and Pt. Ultimately we have to find out the value of sigma n, the normal stress on this plane, and shear stress on this plane, right? So there are forces are acting, right? P1, what is P1? P1 is the force which is due to this stress sigma x. P2 is the force which is due to this sigma y, and Q1 and Q2 are generating from the shear stresses over there, tau xy, right? Now what will be the values? We have already discussed those things, the previous samples. We have seen that the value of P1 will be equals to sigma x into area. In this case the area is BC. P2 is sigma y into the area, that is EB, for this particular triangle wedge, and value of Q1 will be equals to tau xy multiplied by the area this in this section, that is BC again, and Q2, that is also tau xy by multiplying EB, right? Now what will be the values of Pn and Pt then? Now Pn, due to these four forces, the value of ultimate value of Pn will be equals to one component of P1. If this is P1, this will be theta, as because this is theta, so the component of P1 will be equals to P1 cos theta. If this is P2, there will be two components, one in this direction, one in this direction, and the angle will be theta, as because this is theta, so the component will be P2 sin theta, right? Plus, due to Q1, there will be two components, one in this direction, one in this direction. If this angle is theta, so this will be sin theta, plus Q2. For Q2, this is Q2, two components, one in this direction, so this is theta, so for Q2 this will be equals to Q2 cos theta, right? And if we put the values of P1, P2, Q1, Q2, so we will be getting sigma x BC cos theta plus sigma y EB sin theta plus tau xy BC sin theta plus tau xy EB cos theta, right? Now what will be the value of PT, as because we have taken this PT in this direction, and the last case we have taken PT in this direction, that is why we have come to this equation. If we have taken this in the opposite direction, we simply will be having a negative sign, right, over there, but in this case we are taking this as in different direction, right? So what will be the value of PT then? PT, you can see for P1 the component will be P1 sine theta in the positive direction, so this will be positive p1 sine theta, right? For p2, this component will be acting in this direction, so opposite to the pt, so this will be negative p2 cos theta, as because this is theta. Again for q1, this is acting in negative direction, so this will be negative q1 cos theta, and for q2 this is acting in the same direction, so q2 sine theta, that's because this is theta, right? So this p1, if you put the value sigma x bc sine theta minus sigma y eb cos theta minus tau xy bc cos theta plus tau xy eb sin theta, right? Now those are the forces. What will be the stresses? That is the normal stress sigma n and normal tangential stress or stress tau. Normal stress sigma n will be equals to then a force divided by the area EC. A force is sigma x bc cos theta divided by the area, that is EC, plus sigma y EB sin theta divided by EC plus tau xy BC sin theta divided by area EC and plus tau xy EB cos theta divided by area EC. Now BC by EC is what? At the triangle, this triangle BC by EC is what? Is the cos theta, and EB by EC is the sin theta, right? So here also cos theta, here also sin theta, right? So this will be sigma x cos square theta sigma y sin square theta plus tau xy sin theta cos theta plus tau xy sin theta cos theta. So we are getting two type of elements. This element we have already seen the next to next last to last example, and this we have already gone through in the last example. So this is a combination of those two. So after simplifying this, we can get this as sigma x 1 plus cos 2 theta divided by 2. We are simplifying this cos square theta in this formula, so plus sigma y, if we simplify this will becoming 1 minus cos 2 theta divided by 2 plus this will be tau xy, if we take this and this, so 2 tau xy sin theta cos theta, right? Now after further simplifying, we can get sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta, right? And plus if we do 2 sin theta cos theta, then we will get tau xy sin 2 theta. This is the sigma n, the normal stress. Now what will be the value of shear stress? Tau. Again, this is the force divided by area, PT divided by area, that is EC. So this is basically sigma x BC sine theta divided by EC plus sigma y EB, sorry, this was not plus, this was minus, EB cos theta EC minus tau xy BC cos theta divided by EC and plus tau xy EB sin theta divided by EC. Again we are getting this component BC by EC and EB by EC. This is cos theta, this is sin theta. So if we simplify this, this will be sigma x sin theta cos theta minus sigma y sin theta cos theta minus tau xy cos square theta plus tau xy sin square theta, right? Now if we take common sin theta cos theta over there, so we'll be getting sigma x minus sigma y sin theta cos theta minus tau xy. If we take common minus tau xy from these two, so we'll be getting cos square theta minus sin square theta, right? Now just like the last example, we have to multiply and divide with 2 for this part. If we multiply and divide with 2, we will get sigma x minus sigma y by 2 sin theta cos theta minus this term will be, if we simplify this section, you will be getting cos 2 theta, right? Cos square theta minus sin square theta, and this section will be equals to sin 2 theta. So sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. What is this? This is a value of tau.